Let's solve the last problem here, and this one is very different than any of the problem that we did so far because it involved two recursive calls. Let's first of all trace the recursion itself. Like in a recursion, we need a base case. So we started with the base case: if n less than or equal 1, return 1. This is our base case. Then we just returned this nice line here. If you try to trace this recursion, it's going to be hell because it's going to be very big. Now I would like to observe the following. Let's make use of our logic of solving this problem. What is Fibonacci 5, for example? Okay, what is Fibonacci 5? Fibonacci 5 is going to return for us 1, 2, 3, 4, 5. Is going to return for us Fibonacci 5, right? That's all. So let's trace it. The function is going to return Fibonacci of 4, which is the result of Fibonacci of 4, which is 3, and Fibonacci of 3, which is 2. So 3 plus 2 is just 5, which is the Fibonacci of 5. What is Fibonacci of 35? It is Fibonacci of 34 plus Fibonacci of 33. If you try to trace this recursion, it's going to be hell because it's going to be like a tree. Here is an image to understand that. This is function. Let's say that you are calling Fibonacci of 5. So Fibonacci of 5 will make two calls, Fibonacci of 4 and Fibonacci of 3. And Fibonacci of 4 is going to call first 3, then 2. 3 will call 2, then 1. 2 will call 1. 2 call 1. 2 call 1 and 1. In terms of the debugger will call 4, 3, 2, 1. Return to 2, return to 3, go to 1, return to 3, return to 4, go to 2, go to 1, return, 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 go to 3, go to 2, go to 1, 2, 3, 1, to finish all of this computation. As you see, a very big recursive calls here. When you study computer science, you will see a lot of that, and also when you study algorithms class, you will see a lot of that. It's okay if you don't completely get it. I would like here to stress on two things. The first thing is that we managed to trace it very carefully without actually doing all of that or even running the debugger. As simple as this one is going to call this one and this one. And we now are done with tracing. And also you can, from what I did, you know what's going the debugger do exactly, which would be a big mess. Probably the hardest thing for you is how can I come up with such a recursive function by myself? This is going to be hard probably for many guys, especially if the function has a lot of logic. So in algorithms course, you will be exposed to many of that, and expect that your first 20 problems maybe are going to be that hard for you. You cannot get them by yourself. The way that we learn them is by thinking, learning, tracing. Over time, you start to notice the patterns of developing the functions. The last thing that I would like to stress here, if you try to run something like Fibonacci 50, it's going to take too much time. It's going to take too much time. Let's even give a run here. 8 for the first one. Waiting. 35. Here the 35, but the 50 is going to take too much time. What is the problem? Look to this screen. Try to guess what is the problem. Here is a question. How many times this function has been called with F3 to do a computation for it? Twice. Here and here. How many times this function has been called with F2? 1, 2, 3. If you have a recursive function of let's even make it here like let's make it f of let's f of 50. Okay, I would like to show you what's going to happen here. Let's print in. Let's go. Observe here what's happening. You see all of this duplication. One interesting question here is, if something like F7 has been computed and we actually called it like 200 times, in every time we are going to recompute it again and again and again and again. But wait a second, every time you call F, like F10, you are actually doing the same computation and the same result. And this is a lot of duplication, but this isn't duplication of code. When you study algorithms, you know that this is duplication of computation. And this is so stupid. Why are you repeating the duplication and the duplication? So you now know why this is taking too infinite time. Because every number from 1 to 50 is being recomputed too much time. Now the question for you, how to fix that in a very trivial and simple way? Give yourself 5 minutes thinking. The answer as simple as, if you computed something, keep its result and reuse it again when you need it. So let's go here. Here is a very simple solution to that. We're going to define some memory which is going to be a global list for us. And now here let's in the first call we are going to say if the memory is none, then create a memory in terms of the size that we need. For example, let's say I would like to call with n with 35, so we need number from 1 to 35. Let's create 36 value, all of them was -1. The value -1 means it isn't computed so far. Now we're going to compute Fibonacci of n-1 and Fibonacci of n-2, but once the result is computed, we will save it in memory of n. Now before doing this recursive calls in the future, we will first ask if memory of n is computed already or not. If it's computed, we will just use it. There is no meaning, for example, to keep computing f of 25 thousands of times. It doesn't make sense. So the moral of the change is, let's define some global variable, and global variables are bad. Here's just for simplification. And with every call, all what we need to do is to check, is it computed before or not? If computed, return it. If not computed, just compute it and store it. Okay? So now let's run this code here. Observe, in a fraction of second, we computed f of 500 even, not just 50. F of 500 in a fraction of second. You can even, let's compute f of 5,000. It's going to be a very big number. Oh, we got a problem, another problem. The recursion have to keep going here up to like 5,000, which is very, very, very big. But you can like maybe 800, I guess, is going to work. I guess yes. Yes, it's going to work. You see, something like f of 800 is computed in a fraction of second. Why? Because you don't need to keep repeating the computation. Welcome to dynamic programming. You just learned what is dynamic programming. If you didn't get that, that's totally okay. You should get it more in the algorithms course. Feel free to search internet and YouTube on Fibonacci sequence using recursion or dynamic programming. This is very, very, very popular topic, and I think it's good time to be little exposed to it now. I encourage you to put an effort to understand it, but if you eventually didn't get it, that's okay. In algorithms course, you will be like facing too many different types of algorithmic problems, and through all of that, you're going to shape what I call the algorithmic, the recursive mentality, which by the way is important from one side, but is really painful to master it. That's all.